Okay, so let's do a couple more of these to really get in the groove. Make sure that we're feeling confident in this. I see a right triangle, so I could do Pythagorean theorem. I could do trigonometry, but I'm noticing I'm not looking for a side length, so Pythagorean theorem's useless. So instead I need to think, okay, what is it that I'm looking for? I'm looking for an angle. The only way we have to find an angle that you will use in the summer school course is trigonometry. So that's what I'm going to do. I'm going to label things, starting with locating my right angle. Across from the right angle is always the hypotenuse. Not labeled, I'm not going to use it. Then I'm going to label O and A. So next to my angle is made up of two sides. One side is the hypotenuse. The other side is next to my angle. That makes the 33 the adjacent leg. The 22 is neither of those sides. It's on the other side of the triangle. The 22 is the opposite leg. Therefore, I can see if I throw out the hypotenuse, that means I'm going to use a tangent equation, SOHCAHTOA. So I'm going to go ahead and note that I'm going to use tangent, and then I immediately followed up with what angle I labeled O and A from, which would be x. That will be equal to some ratio. The ratio for tangent is always the opposite leg over the adjacent leg. So I'm going to put 22 over 33. Since neither of those sides were x's, I'm not going to cross multiply. To find an angle, you do inverse. Angle and inverse should be pulsing through your head when you do these problems. Angles are solved by inverse. So to get x by itself, I'm going to do tangent inverse to both sides of the equal sign. So I'm kind of skipping showing my work here, but I essentially took tangent inverse here, so that it cancels, and I just have the x left over. So we need to note that I'm ready to put this in my calculator. Tangent inverse of 22 over 33. And it should be about 34. I see 33.69, so about 34 degrees. So if you're getting something ridiculously small, chances are you forgot to put inverse. Sometimes it means that you chose tangent and it was sine or one of those types of mistakes. Most of the time when we give you angle problems, there'll be some number between 5 and 85 degrees is a reasonable number you could get. So let's look at example 4. Right triangle, Pythagorean theorem, trig, fair game. I'm looking for an angle, so I'm not going to do Pythagorean theorem. I have my right angle, so that means I can quickly identify my hypotenuse. And then this angle is next to this side, so I'm going to use the adjacent leg. I didn't label the opposite, so I won't use sine, I won't use tangent, so SOHCAHTOA tells me to use cosine. So I'm going to write cosine of my angle and set it equal to the adjacent leg over the hypotenuse. Cross multiplying would not be helpful. To get x by itself, I need to take cosine inverse of the left side. I need to take cosine inverse of the right side. So that means those are going to cancel. I'm going to get x by itself, and x will be found by cosine inverse of the fraction of 11 over 12. If you're finding an angle, you're going to use inverse of one of our trig functions. When I type that in my calculator, I see 23.55. So I'm going to round to the nearest whole number. It's about 24 degrees. I think I'm going to stop on that one there. I'm going to skip down to, what am I going to do? I'm going to do number 10. So this will be the last one, and then I'll start a new video to finish it up. It says, if tangent of x is 6 over 8, find the remaining trigonometric functions. So you'll see neither of these say x equals. I don't care what x is. I want fractions. I want ratios, which means we basically already did this problem yesterday. So I'm telling you at the beginning, I know what tangent of x is. If I know tangent, SOHCAHTOA, I know the opposite leg, and the adjacent leg in this picture, which isn't super helpful if I don't know where the angle is. So remember, your angle can be anywhere except the right angle. The right angle is already destined to be across from the hypotenuse. So I need to pick another spot for the angle. I always pick the bottom corner for no real reason other than it just feels right. So next to it would be the adjacent leg. Across from it would be the opposite leg. So wherever your angle is, you can go ahead and label O and A. Hypotenuse should be already set. But this problem said the opposite leg was a 6 and the adjacent leg was an 8. So I actually have some numbers in this picture finally. But the question here is wanting cosine of that angle. So katoa. All I really need to know is what is A and H to make a fraction out of them. So if I look at the picture, I know A, the adjacent leg is 8, but I don't know our hypotenuse. I'm missing a side in this right triangle. You can find missing sides of right triangles using the Pythagorean theorem because I know my two legs are 6 and 8. I don't know the hypotenuse. So I'm putting y on its own side of the equal sign because it's the hypotenuse. The two legs need to be squared and added. 36 plus 64 is 100. And since I have a squared, I'm going to solve by square roots. And I'm not going to use a factor tree because the square root of 100 is 10. Keeping in mind that when we give you the algebra question, don't forget your plus or minus. But for a length, for a geometry question, throw out the negative. It's going to be a positive length. So I have a hypotenuse of 10 in this problem, which means I'm ready to finish up here. Cosine of that angle is the adjacent over the hypotenuse. And technically this can be reduced. Sine of an angle is always opposite over hypotenuse. Well, my picture is labeled. The opposite was a 6. We just said the hypotenuse is 10. And technically that can be reduced. I'm not doing inverse here. And the reason is, inverse is when I ask what's the measure of this angle, which is not what I'm asking here. I just want to know what is cosine of that angle, what is sine of that angle. Technically, I could find the angle using inverse. It would just be a waste of time.